Hello students, a warm welcome to all of you at AriserTalent. So, we were discussing about class 10th chemistry chapter number 3rd, that is metals and non-metals. In this sequence, we have discussed about some of the introductory part regarding the metals. Then we have discussed about the electronic configuration of the metals and place of the metals in the periodic table. So, we have discussed that in the periodic table, metals are basically placed in the left hand side of the periodic table. In the right hand side, non-metals are basically situated. So, if we start moving from left to right, we can see that the non-metallic character will going to decrease. And if we are going from top to bottom, we can easily observe that the metallic character will going to increase. So, it means if we are going from left to right, metallic property will going to decrease. But if we go from top to bottom, we can easily see that the metallic character will going to increase. So, the metallic character will increase in going from top to bottom. Now, you can easily see from this periodic table description that the metals and non-metals are separated by a zigzag line. You can easily observe here a zigzag line is separating non-metals from the metals. So, this zigzag line is basically the metalloids. So, the zigzag line that is separating metals and non-metals are termed as metalloids. So, this part is known as the metalloids. In this metalloid series, we have certain examples or the certain elements which show characteristics of both metals and non-metals. So, this zigzag line, we have some elements, and the metalloids we have are, these metalloids will be boron, silicon, germanium, antimony, tellurium, and polonium. So, these are the list of the elements which are showing both metallic and non-metallic character and separated by a zigzag line is termed as metalloids. So, we can see here metal and non-metal are basically separated by the metalloids. Now, we have discussed that electronic configuration of an element in which the outermost shell will have a 1, 2 or 3 electrons will be considered in the category of the metals. So, our next description is, if valence shell have 1, 2 or 3 electrons, we can say that it will exhibit the property of the metals. Now, we are going through our next discussion, that what are the physical properties and the chemical properties of the metals and non-metals. So, firstly, we will deal with the physical properties of the metal. So, this question is very important from your exam point of view, that what is the difference between metals and non-metals on the basis of their physical properties. So, the first description was electronic configuration. So, we know that metals have the free electron in their outermost shell. So, if they lose their electron, they will acquire the complete stability. So, metals are termed as electropositive element. Electropositive elements are those elements which have a tendency to lose their electron from the outermost shell. Now, in the first property of the metal, we can easily see that metals are solid at room temperature. Metals will only be solid because the metals are having a solid rigid structure. Now, there is one exception, that is mercury. Mercury is a metal, but in spite of being a metal, it is in the liquid form. So, the one exception here is mercury, and which is basically in the liquid form. So, mercury is liquid. So this will be one exception here, otherwise all the metals you can see around us will be solid in nature. Now we are dealing with our next property. Metals are lustrous and can be polished. Now metals are lustrous and they can be polished. This property means luster is a property having a shiny appearance. So metals will have a shiny appearance and they can be polished easily. So something having shiny appearance will be categorized in the category of the metal. We have certain example here like gold, silver, copper. All of these metals will have a shiny appearance. So we can say that metals are lustrous. So example in this category we have are gold, silver and copper. So these are the certain examples which are showing that metals have a lustrous property. Now we are moving with our next property. Metals are hard. Metals are generally hard, and as you have seen that copper, aluminium, gold, iron, these are all hard structures. So metals are hard because the solids have a strong bond of attraction or the strong force of attraction between them. But in spite of that, there are two metals which are very soft and can easily be cut with a knife, and these are sodium and potassium. So gold, aluminium, silver, iron are the hard metals, but the two exceptions we have are sodium and potassium. So sodium and potassium are the two metals that can be easily cut with a knife. Now we have our next property, that is property number 4. Metals are malleable. It means malleability is the property of a metal that if something or some metal is hammered or beaten, they can acquire a position of the thin sheets. It means if we beat a metal sheet, it can be form a sheet. The common example we have in our day-to-day life, we have easily seen that the aluminium foils we used in our kitchen are the thin sheets of aluminium. It means if the metal is hammered, it will acquire a position of the thin sheet. So this property is basically known as malleability, and we have many examples, but the gold and silver are the best malleable metals. So gold and silver are the best malleable metals, and aluminium sheets or the aluminium foils we have seen in our day-to-day life are the common example of malleability. Now we are moving to our next property, that is property 6. Metals are ductile. Ductility is the property of the metal. If the metal is beaten or hammered, it will acquire a shape of the thin wire. So the property of making a wire from the metal is termed as ductility. So we have many examples in the ductility. Copper and aluminium are the ductile metals. Gold and silver are also the ductile metal. So gold and silver are the best ductile metals, and the copper and aluminium are the second best ductile metals. So the gold and silver are much expensive. So in spite of that, we are using copper and aluminium wires for electrical wiring purposes. So we have two examples. If we are considering gold and silver, these are the best ductile metals. If we are saying about copper and aluminium, these are second best ductile metals. So in spite of gold and silver, we use copper and aluminium for making the wires because the gold and silver are much expensive metals. Now we are moving with our next property. Metals are good conductor of heat and electricity. As we know that metals have a free ions associated with it, we have seen that in the outermost shell of an atom of a metal, we have 1, 2 or 3 electrons. So the free electrons are basically responsible for the conduction of electricity. If we supply or if we connect a battery with a bulb, or we have taken a conductor over here. So if I am taking conductor here, it means that conductor will be made up of the metal. So in this case, complete conduction will take place due to the flow of the electrons and the bulb will start glowing. But in the second case, you are observing that we are using thermoplastic. So if I am using conductor, current will start flow. If we are using thermoplastic do not have a free electrons associated with it, so the current cannot be flowed in this process. So metals are basically good conductor of heat and electricity, as copper is a good conductor of heat and electricity. That's why we are using copper wires in our electrical wiring system. Silver is the best conductor of the electricity, but in spite of that, it is being very expensive, so we are using copper instead of that. So the next example we have is silver is the best conductor of electricity. Silver is best conductor of electricity. But silver is expensive. Being expensive, we are using copper wire in this case. So copper wiring is used. So this is the description about the conduction property of the metals. Now we have our next property, but we can easily see here the free electrons propagate and electricity is produced due to the free electrons present in the outermost shell of the atom. Among all the metals, silver is the best conductor. Copper and aluminium are the next best conductors, but silver being expensive, so we are using copper and aluminium wiring. Now we have our next property, that metals have a very high density. As we know that metals are very heavy and density is directly proportional to the mass, because we have a formula, that is density equal to mass upon volume. So we can easily see from here that density will be directly proportional to mass. It means metals are much heavy, so their density will be very high. Density of the mercury metal is 13.6 gram per centimeter cube. It means they have a very high densities. Now the melting and boiling point of the metals is very high. So we can see that as the metals are very hard, it will take a much time or the much temperature to melt and boil. So sodium and potassium metals have a very high melting boiling point. Among these, we have a tungsten, that is a metal having the highest melting or boiling point, that is 3430 degrees Celsius, which is very high. So tungsten metal will have a high melting point. In the similar way, the melting and boiling point of the iron is also very high. It is approximately 2500 degree Celsius. Now we have our next property. Metals are sonorous in nature. So sonorous means if we beat the metal or if we want to produce the sound, the metals will have a tendency to produce the sound effect. So the property of producing the effect of the sound is known as sonority, and the metals are sonorous. If we want to make the sound, we will beat the metal and it will start producing the sound. So we can say that metals are sonorous in nature. Now this is all about the metals we have discussed. We know that we have the various properties we have discussed here. First property we have discussed that metals are hard. They are very hard. Sodium and potassium are the exceptions here. We have discussed about the thermal and electrical conductivities. We have discussed about the melting point and the boiling point. The two properties, malleability and the ductility. We have discussed that metals are sonorous in nature. One more property is there, that metals are very rigid. Rigid means they have the hard structure belonging to them. But if I am talking about hardness or rigidity, these two factors are very comparable to each other, because melting and boiling point properties are completely depend upon the hardness and rigidity of the metal. So these are the general physical characteristics of the metal. Now we are moving to our next topic, that is non-metals. So non-metals generally have 4, 5, 6, 7, 8 electrons in their outermost shell. So electronic configuration of the non-metals, they have 4 to 8 electrons in their outermost shell. Now we are considering the examples here. Suppose I am taking carbon, nitrogen, oxygen and argon. So these are the gases and these are generally the non-metals. So if we talk about the electronic configuration of these elements, we know that carbon is having a atomic number 7, so its electronic configuration will be 2, 5. This is for nitrogen. Carbon is having atomic number 6, so its electronic configuration will be 2, 4. If I am considering nitrogen, atomic number 7, electronic configuration is 2, 5. If we are having oxygen 8, it will be 2, 6. If I am considering argon, argon will having atomic number 18. So its electronic configuration will be 2, 8. To 8, 8. Now we can see that in their outermost shell they are having 4 to 8 electrons. In the case of the carbon we have 4 electrons, in nitrogen we have 5 electrons, in oxygen we have 6 electrons and in argon we have 8 electrons. So we can easily see that the non-metal will have 4 to 8 electrons in the outermost shell, but in case of the metals we have only 1, 2 and 3 electrons in their outermost shell. So these are considered in the category of the non-metals. So this is all about the electronic configuration regarding non-metals, and in the periodic table we have seen that non-metals are basically placed on the right hand side of the periodic table. It means in moving from left to right, non-metallic character increases, and in moving from top to bottom the non-metallic character will going to decrease. So if we consider position of non-metals, we have easily seen that from the periodic table they are situated in the right hand side. Second thing is about the non-metal is that in moving from top to bottom, the non-metallic character will going to be decrease. But if we are moving from left to right, the non-metallic character will going to be increase. So if we are moving from left to right in the periodic table, the non-metallic character will going to increase, but from moving from top to bottom, the non-metallic character will going to decrease. So this is all about the electronic configuration and the position of non-metals in the periodic table. Now we are moving to the general properties of non-metals. So the first property that we have discussed is about the hardness. Metals are very hard because of their rigid structure. On the other hand, non-metals are just opposite to it. Non-metals are not generally hard in nature, they are the soft metals. It means that the non-metals are brittle. If we hammer them, they will be broken into the pieces. Second property we have discussed regarding the malleability. Non-metals are not malleable and not ductile because if we hammer them, they cannot be converted into the sheets, they can be broken into the pieces. For example, we have sulfur and phosphorus. If we beat them, they can be formed into the powdered form. It means they can be broken into the some form of the substances. Now, non-metals are the bad conductor of heat and electricity. This is because they do not have a free electrons for the conduction. But one exception is always there. In spite of being non-metal, graphite is a good conductor of electricity because of its carbon-carbon bonding present in it. So the exception here is graphite, and this is due to the presence of free electrons. Next property we have discussed about the lustrous. Metals have shiny appearance, but the non-metals are non-lustrous. They cannot be polished or they cannot be have a shiny appearance. But again, there is one exception. We have seen the salt. In salt, we have a iodine, and we can easily see that the salt crystals have a shiny appearance. So the exception here will be graphite and iodine. It means the graphite and iodine are lustrous and have a shiny appearance. Next property we have discussed about the melting and boiling point. Metals generally have a very high and melting boiling point that we have discussed about the iron and tungsten. But in case of the non-metals, the melting and boiling point is generally low. But in case of the diamond, the melting and boiling point is very, very high because diamond is a very hardest substance. So, what is the exception? In case of non-metals, there exists low melting and boiling point because the metals are generally not much hard, but one exception is here. Exception here is diamond, because diamond is a very hardest metal. Next property we have discussed about the rigidity. Non-metals are generally not rigid because they are not very hard, because they are the soft metals. Next property we are going to deal with about the density of the non-metals. The density of the non-metals is very low as compared to the metals. In case of the metals, we have seen that the density of the mercury is 13.6 gram per centimeter cube, but the density of sulfur is only 2 gram per centimeter cube. So, if I am talking about the factor density, in case of non-metals, density is low. Density is low. If we are taking an example for sulfur, sulfur will have a density of only 2 gram per centimeter cube. So we can observe that the density for the non-metals is generally low. So these are some of the properties regarding metal and non-metal, and in both the categories we have seen some few exceptions. That is, some exceptions are graphite, diamond, iodine in case of the lustrous, melting, boiling point properties. So this is all about the physical properties of metal and non-metal. This lecture is over for today. We will deal with our next property, that is chemical property, in our next lecture. Thank you so much and have a nice day.